Today I'm going to be presenting my secondary data analysis research for APN 775. On the agenda is the objective, methodology, the results of the study, the conclusion of the study, and the funding source. The objective of the study was to examine the relationship between choline supplementation and physical fitness performance among male athletes between the ages of 18 to 65 years old. There were three specific aims of this study. The first aim was to assemble a large set of data in order to help determine whether higher intake of choline will help to reduce the fatigue among athletes. We hypothesized that athletes who took a higher dosage of choline per day will have less depletion of choline throughout physical activity, which will lead to less fatigue and optimal performance levels over a longer period of time. The second aim was to utilize the dataset to determine the amount of choline needed to enhance the physical fitness performance levels. We hypothesized that athletes will need to take at least the recommended amount of choline per day in order to enhance their performance levels. However, this intake may be higher depending on rates of choline depletion throughout the exercise. The third specific aim was to utilize the data set to determine whether increased choline intake does reduce reported infections and colds that are common among athletes. We hypothesized that the increased amount of choline will reduce the risk of infection and colds among athletes due to an increase in immune support and decrease in fatigue levels throughout high endurance time periods. This secondary data analysis uses quantitative data from NHANES, which establishes the variables that will be used for the study. We then transferred the data to Excel to clean the data and prep it for the Stata software. Once this was completed, we imported the data into Stata and analyzed the data through a linear regression. This provided us with an ANOVA table where we examined the relationship between the independent variable and each dependent variable. Once this was done, we created a linear regression model to visualize the relationship between the independent variable and each dependent variable. The model was then interpreted through the form of a slope, which indicated that if there was an upward slope, there was a strong relationship between the two variables. If there was a downward slope, it indicated a negative relationship between the two variables. And if there was a horizontal slope, then that indicated a zero relationship between the two variables. If the starting point of the slope was higher than 0 on the y-axis, this indicated that high levels of choline would need to be taken in order to see an increase in physical fitness performance levels. The results of the study showed that there was no statistical significance found between total choline and each dependent variable. However, on the linear regression model, there was a trend line that was greater than 0 on the y-axis when we were examining the relationship between choline and VO2 max. This was interesting because it shows that you would need to take a higher amount of choline in order to see a better physical fitness performance level among athletes. However, in conclusion, the p-values did not show any statistical significance between choline and any of the dependent variables. Although the linear regression model trend line did display a slight relationship between choline and VO2 max because it was higher than 0 on the y-axis, this was not a statistically significant enough result. Therefore, we're unable to conclude the precise relationship between choline intake and athletic fitness performance levels. The funding source of this project was the American College of Sports Medicine. Thank you for listening.